Hi guys, and this is your video for number 3 on your vector applications worksheet. So, reading this problem, a pilot wants to maintain a course of 40 degrees east of north and a ground speed of 300 miles per hour. So, first thing we're going to do, draw a picture. Alright, so we've got our coordinate axis set up. Never eat soggy waffles, not Wheaties, because apparently that is not okay. He wants to maintain a course of 40 degrees east of north. So we're starting at our north and we're going 40 degrees east, so this way. And this in here is 40 degrees, and then the magnitude of that is 300. But also, there is a 45 mile per hour wind blowing in the direction of 20 degrees west of north. So starting at our north, we're going west 20 degrees, just a short little vector right here. This angle right here is 20 degrees, and then the magnitude is 45. So, we are given the resultant vector. We are given the course that he wants to maintain and the bearing that he wants to maintain that speed at. So, we want to find what he needs to set his speed and his bearing to, so that when the wind is accounted for, he is going on a course of 40 degrees east of north and a ground speed of 300 miles per hour. So, before we get into all that, first thing we should do is we should find the component form of these two vectors. So, for our crimson vector here, we have the magnitude is 300, and then we have this angle here is 40 degrees, but remember when we're working on our calculator, we don't want the bearing. We want the angle measurement from the positive x-axis to our vector moving counterclockwise. So since north and east, so this angle right here is 90, if we go from the positive x-axis up to here, this one is 50 degrees. So the component form is going to be the magnitude of 300 times the cosine of that angle 50, and then the magnitude of 300 times the sine of that angle 50. Punching that into your calculator in degree mode, you should end up with 192.8 and then 229.8. Now finding the component form of the wind vector. So same thing, we have to find that measurement from the positive x-axis. We know that going from this, our positive x to positive y, gives us 90, and then we add on that 20. So this whole measurement right here of this angle is 110 degrees. So finding that component form, magnitude is 45 times the cosine of 110, 45 times the sine of 110. Punching that into your calculator in degree mode, you should end up with negative 15.4 and 42.3. Now, like it says in our problem, we are given the resultant vector. So that is the vector that when we find the sum of the wind vector and the vector that the pilot has set his course at, that's the vector we are going to get. So we're looking for a vector x, y, so that when we add it to the vector, oh, not my crimson vector, we're adding it to my blue vector. We're adding it to the wind vector, negative 15.4, 42.3, so that when we add those together, we will end up with my crimson vector of 192.8, 229.8. So, getting this into our component form, we would have 192.8 is equal to x minus 15.4. So that's my first component in the vector in my resultant vector. And then 229.8 is equal to y plus 42.3. Now we have to solve for x and for y. So for our first one, x is equal to, we'd add that 15.4 over, so 192.8 plus 15.4, that will give me my x component, and then my y component, y is equal to 229.8 minus 42.3. Once we do that math out, we will end up with 208.2, 187.5. So this gives us our component form, but remember, we want to find his bearing and his airspeed. So let's start with airspeed. Magnitude. The magnitude of this, remember, we take the square root of our x component squared plus our y component squared. Working that out, you should end up with 280 once you round it. So 280 miles per hour is his airspeed. Now we have to find his bearing. So to find his bearing, we have to find our direction first. Oh my goodness, hello. All right, so direction. To find the direction, we take the inverse tangent of our y component divided by our x component. Doing this out, we end up with 42 degrees. Okay? All of this looks good. It's all matching up. This is in quadrant 1, and this is in quadrant 1. So, drawing my vector out, we know that it's going to have 42 degrees from the x-axis. So, something like this. Okay? But remember, we don't want the measurement from the x-axis, we want its bearing. So that's the measurement from the north to my line. We know this angle right here is 42. So if we want to find this angle, this is getting real ugly, I'm sorry. This is going to be 90 minus 42. So its bearing is going to be 90 minus 42, which will give us 47 degrees. Hopefully that was helpful. Let me know if you guys have more questions as you're working through these.